நாளைக்கு நான் கொண்டு வரேன். ஓகே ஓகே ஓகே. சரி.
நான் உங்களுக்கு அனுப்பியிருக்கேன்.
சரி. Good afternoon, friends.
Good afternoon, sir.
Yeah, good afternoon. So I hope you're all doing good. Every week we are having this particular lab hour to learn the simulation ideas for different backgrounds of chemical engineering. Normally Siva ma'am used to have this session. So in the absence of Siva ma'am, I have joined with Professor Gobikrishnan sir for you. Today we are going to discuss the simulation process of shell and tube heat exchanger. Okay. I will tell the procedures first. You all start to do the process, and after some time, after my discussion, Gobi sir will join with us, and he will explain some of the backgrounds behind this particular experiment. Okay. So now I share my screen with you. Here I have shared a Word file which shows all the steps. So I'll tell the algorithms or the procedures, whatever we are going to file. Simultaneously, we start to do in our screen also. Your laboratory app also you just open, and let's start to do that. Okay. Yeah. So as usual, we will start with the tool DWSim, the simulator. Okay. So here we go with new process simulation model. I hope everyone knows this. Okay. Now we have to define the compounds. That is our first step. So in this experiment, shell and tube heat exchanger. So what are all the compounds we are going to have? So there are two compounds we are going to select in this place. The compounds which are necessary for this particular experiment. That is, we are going to make the choice of methanol and water. So here you can see in step 4. So every week you are all doing that, the first step of selection of compound. So I hope you all know this. So we select methanol and then we select water. Okay. So then we proceed with the next step. Now, so what is the modeling package which we are going to use in this place for the simulation? So the usual package what we use, that is this Raoult's law. The same here also we use. Okay, you select this Raoult's law and then you just add it. Vishnu, is there any doubt? You have raised your hand. Okay, so we have to add this Raoult's law and then next. Okay, so we have to select the package, property package we have added. Then we have to choose the unit window. Units we have to fix what are all the different types of units we are going to use. You all know SI, CG, SENG, all these types we use. Here particularly we select this C5 and then these steps are over. So initially in every simulation configuration, we do all these steps, we select compounds and then appropriate property package. This property package is nothing but what is the type of mathematical equation we are going to use. So you would have to come across several mathematical principle or equation in your theory subject you would have to come across. So I believe that you know that very well. And then the units which we are going to use. Okay. So once this configuration is over, you just give finish. And in this place, we are going to work on material stream. Okay. So we have to take the material stream in our working space. So all of you click this material stream and drag it and keep it here. So what are all the different types of processes being happen in this particular experiment? You just look at the title of this experiment, shell and tube heat exchanger. What we are going to do, we are going to see that when we give the input of water and methanol, and it will be mixing up, and when it comes out, what about the temperature of water and methanol again? Okay, that's what we are going to study. So there are two inputs, one is water, another one is methanol. And again, we will get output also, again, water and methanol in different temperature after doing that process of heating, heat exchanging. Okay, so we have to define all our inputs. So we have to take this material stream. So this material stream, you all know we have to change the properties. So the first material which I take, we are going to give water as in. So here you take water in, water in. I give this object name as water in. So in a real-time situation, you all know that what are all the different properties when you give your input and when you want to have your output. You all know the different properties. Here we make some assumptions on this input properties. So water in, we take the temperature as 10, okay, 10 degrees Celsius. Let us take the pressure as 1 bar, okay, and then we take the mass flow as 15,000, okay, we change that 15,000, okay. So these are all the few changes I am doing. I am assuming for this experiment, what is input I am giving? The first input is water, water in. The temperature I am assuming initially it is 10 degrees Celsius and the pressure is 1 bar and mass flow as 15,000 kg per hour. Okay. Now, similarly, we have to give the input, the next input. What is our next input? Okay. Yeah, before that, we have to do some more modification in this input, that is the properties of compound. Okay, so how much methanol we want to give, how much water we want to give. So let us say it is completely water and it is not methanol. Here the mole fraction of methanol will give it as 0. We will give it as 0. We have to change it. Yes. In input data itself, you go for compound amounts, the mole fractions, I say it is 0. Accept changes you just give. Here it is 1. Okay. So these are all the properties of input variable here. Water in we have to do. So I have done all the changes. What are all the changes? I have given the stream conditions first of all. The stream condition is temperature and pressure is a flash speculation And then temperature I gave 10 degrees Celsius, pressure as 1 bar, mass flow is 15,000 kilogram per hour. And then I have changed the compounds, that is the amount of compounds, methanol is 0 and water is 1. Okay, so we have defined water in. Then similarly, you do the next input, okay, next material, do double click on that, MSTR02. You just define that is as methanol in. I hope you're all following me. Is there any doubt? Please stop me. Do not hesitate to stop me. If you have any doubt in any of the step, please ask. Please ask. Can I get some response? You could. I hope you could follow this, whatever I'm saying. So now
Yes.
methanol in. Yeah, thank you. Methanol in, we have to give. So here again in methanol in, we have to change the properties. That is not changing the properties. We have to present the stream conditions. In what condition we would like to work on it. That's what. Okay. So please take the step 3. Change the temperature to 80 degrees Celsius. 80 degrees Celsius. Okay. And then we take the pressure bar as 5. Pressure bar is 5. And then the mass flow is 25,000 kg per hour. 25,000 kg per hour. Okay. So I hope you all have done this. Temperature is 80 degree and pressure is 5 bar, mass flow is 25,000 kg. So it is not here even we have mentioned as change in the steps what we have typed. Here we are assuming for this particular values we are doing our simulation. So you all know in real time what are all the different values are recurring, or I can say what are all the stream conditions are recurrent in the specified situations. You should know to work accordingly. Okay. Now, what about the molar function here? So earlier in water is full amount and methanol is 0. So here we are going to take the mole fraction as methanol is full, then it's obvious that what will happen? Water will become, methanol is full, we have to take methanol as full, then water will become 0. Okay, methanol is full, water is 0. That's what we are going to take here, the mole fraction. Okay, so now we have defined the input parameters, water in, methanol in. Similarly, we need to do now the variable of definition of variables of water out and methanol out. Okay. So we have to do water out and methanol out. Now, sir, are we going to define anything here? Because we are going to simulate water's output. So we need not to define any of these things. Sir, what will be the, how do I want to have my output? We are not going to do that in this stage. Only we are going to know about what type of output we will give. So I have named here this output as water out. Similarly, I do in this place another output variable I define and I call it as methanol out. Okay. Now what is the next step? Now we have defined what is input, what is output. So what is our focus here in this place? We want to do the heat exchanging. Okay. So we have to make the choice of heat exchanger from the flow sheet object. So you just look at here, where do we get heat exchangers? See here, many menus are available. Streams, pressure exchanger, separator tanks, mixers, okay, exchangers. In this exchanger, you just make the choice of heat exchanger. So the cooler in exchangers, cooler exchanger is there, heater is there, okay, heat exchanger is also there. We are doing this rigorous heat exchanger model. So you just make the choice and do this operation here. Okay, so you just keep it here, heat exchanger. Now you just look at, so what are we going to do? Now what we have to give, what is input, what is output, everything we have to define. So we have to define the inlet stream and outlet stream in this heat exchanger. Okay, so let's do that. Let's do that. So I give the name here, instead of HE01, I give it as heat exchanger. Okay, heat exchanger. So what is inlet stream for us? I give water in the way you give, the way you present. Uh, you all know that certain situation, the input you can give in any order, it won't affect. In certain situation, it will be affecting. You know very well than me, in what situation which has to be given first, the other one have to given later. Like, okay, some of the situations, suppose some of the compounds what we take, it won't mix up, or some of the compounds it will be mixing up, or the heating properties will be varying. All such things you should consider. So in this particular situation, I take methanol in and methanol out, and then inlet stream we take water in and water out. Okay, okay. So please check once whether you understood. So in property editor window, we select methanol in, methanol out, water in, water out. So we have to change the calculation properties now. We have to change the calculation properties. So in calculation parameters, here in this calculation parameters, we have to change this is as, what we do shell and tube exchanger. Okay, what we do, shell and tube exchanger. Okay, we do shell and tube exchanger rating. That's what we are doing. So we have to change that here, shell and tube exchanger rating. Okay, now there are different types of flow direction, counter current or co-current, and in this place we make the choice of counter current. And then, so here all for counter current, all these are fixed. Only one thing is possible, the heat law can be changed. Okay, the heat laws can be changed. All the other are fixed. Okay, all the other are fixed. Okay, so if we want, we can change this heat loss. Now at present, I keep everything as it is, whatever it is there. Even later, you can practice yourself by considering these pressure values, pressure drop, or all these things. By the way, you can change it also. Okay. Now, the next step, click on shell and tube exchanger properties. If you click here, edit, you can see here. All of you see, I have clicked here, edit shell and tube heat exchanger properties. So these properties have to be modified now. Okay. So how are we going to modify? You can follow this. All of you do these steps. In shell side configuration, cell in series 1, shell passes 2, cell in series 1, shell passes 2. Okay. Then we have to do internal diameter. Here it is 500 mm. Let us take it as 1000 mm. Okay. Now fouling factor we take it as 0.00035. 0.00035. Okay. Then after shell, change baffle spacing and baffle cut also. So that is also we have to do. That is 250 and 20. Let us keep as it is. Then length here it is 5 meter. Then we have to do on tubes. Let's start to do with tubes. Internal diameter is 15, external diameter is 20. Internal diameter let us keep as 15 mm, and then external diameter let us keep it as 20 mm. Length is 5 meter. Then this fouling factor is again here also 0. Let us keep it as 0.00035. Okay, then roughness we keep it as 0.05. Here already it is 0.045. We give exactly 0.05. Then after roughness, thermal conductivity we change. That is 60. Okay, so passes per shell. Then that is 4. We take here our model is 4, not 2. Then tubes per cell 1024. Tubes spacing is we take as tubes per cell we consider as 1024. Okay, so then we take tube spacing as 25. Yeah, then the tube layout, there are different types of layout. Okay, triangle, rotated triangle, square, rotated square, and so on. Here we take it as square. Okay, and then fluid in tubes. So initially our assumption is cold. Okay, so we take this. Now what we have to do, we have to run the simulation. Okay, we have to run the simulation. We have to run the simulation. Please go through once whether you have understood whatever I have discussed with you, whatever the procedures I have said, whether you could follow it. Please check once. Please go through once whatever I have said. So once you do this, please run the flow sheet. How we have to run the flow sheet? Every class we are doing, click F5, or I think you could see my cursor where I'm clicking solve flow sheet F5. Suppose you are having lesser version than what I have here, less than 6, you will be having a menu called run the simulation or solve flow sheet F5. So you just run it. So whatever we have made it as inputs, we will get the results. Now, so after the calculation, what you do, you just click on heat exchanger again. Okay, you click on heat exchanger, you do double click and check cold fluid outlet temperature. Cold fluid outlet temperature here. Okay, you can see that is You just see here, we have calculated and it came here 67. Hot fluid outlet temperature 41 point something. Global heat transfer coefficient, heat change area, heat change. So all these values you will be getting. Okay. So please check once, all of you. So I have presented some closer values in this table. Verify here in step 20. I think you could see the values for whatever assumptions initially we have made. You can see all these values you will get. Okay. So these are all the output one set we get here. And now, sir, what are all the other outputs we could derive it? Okay, what are all the other output we could get here? So for that, we can go to insert master property table. So please keep separately. You double click. So here we can get different types of table. Okay. So I would like to get the result of heat exchanger stream-wise results. What I would like to get now, I want to have heat exchanger stream-wise results. So let us do that. So I give the name here, heat exchanger stream-wise results. Heat exchanger stream-wise results. Okay. So all of you type there. And what is the object type here? That is material stream. What are all the objects? So in material stream, we have 4 objects. What are all the 4? We have water in, water out, methanol in, methanol out. So you select all these 4. And what are all the property I would like to study in this place of heat exchanger stream-wise results? So we have to tell there are so many properties which are given here in this package. But what are all the properties exactly related with our simulation, as well as what is our objective also, what are all the results we would like to have. So please select temperature, pressure, mass flow, molar flow, and so on. Okay, so let's do that. Temperature, pressure, mass flow, molar flow, then molar fraction mixture of water, molar fraction mixture of methanol. Okay, molar fraction mixture. So please scroll it and verify it. Okay, molar fraction mixture, molar fraction is coming, molar fraction mixture. Yes, see here we have molar fraction mixture, methanol. Okay, molar fraction mixture, methanol. Similarly, we want to have molar fraction mixture of water. See here we have molar fraction mixture of water. Yes, here we have. Okay. So we have to make the choice of properties, whatever we want to have. So if we close this window, we will get the table of results. So you can see here the table of results, heat exchanger stream-wise results. So the temperature, initially it is input 10 degrees Celsius we have given, but what is water out? 66.6148. Same time, methanol in initially it is 80 degrees C, the output is 40.916 degrees C. Okay, so what we can understand here, certain input we have given, and in the same tube we have given both input, water in and methanol in. But what happens finally when it comes the output? Okay, the different types of output. Okay, the temperature, pressure, mass flow, molar flow, everything varies. Okay, so these are all the different parameters we can find it as output. Sir, can we have any other output? You can find out any output which you would like to get. So let's try one more output. I suggest you with again here heat transfer coefficient. Let's try with heat global heat transfer coefficient. Global heat transfer coefficient. Again insert master property table. Okay, do double click. What we are going to do? Global heat transfer coefficient. Global heat transfer coefficient, which we are going to find out. Now,
அது இன்க்ளூட் பண்ணிட்டேன். இப்போ டியூஸ்டே 7, 8 ஃப்ரீயா இருக்கும். ஃபர்ஸ்ட் இயர்
yeah, we will take in this way. In object type, you take heat exchanger. In object type, you take heat exchanger. We will give the name of this as heat exchanger results. Heat exchanger results. So in property itself, we can find actually directly the global heat transfer coefficient. Okay, so we need not to do separately. It is one of the property. So please do the corrections what I have done. In name, you just write heat exchanger results, and in object type, you take heat exchanger. In object type, it is heat exchanger. So you just choose the heat exchanger. Okay. Now here in this, we are going to find the property as global heat transfer coefficient. So here I have clicked. I hope you could see that. In the property, you click global heat transfer coefficient U. And can we have many more properties like that? Yes, whatever you want, you can have. Here we take heat exchange area. Okay, heat exchange area. Then heat load, cold fluid outlet temperature, then hot fluid outlet temperature. Okay, then we take this logarithmic mean temperature difference, LMTD. Okay, and then finally thermal efficiency. We'll take thermal efficiency. Okay, so the first table we have found heat exchanger stream-wise results. So the streams are nothing but water in, water out, methanol in, methanol out. So now we are finding out heat exchanger results. So what are all the different heat exchanger properties? Here we have made the choice in this result table. Global heat transfer coefficient, heat exchanger area, heat load, cold fluid outlet temperature, hot fluid outlet temperature, logarithmic mean temperature difference, that is LMTD, and then finally thermal efficiency. So you'll get all these outputs in this table. I think you could see this result. See here, all the values are presented. What is global heat transfer coefficient, heat exchange area, heat load, cold fluid outlet temperature, hot fluid outlet temperature, logarithmic mean temperature, thermal efficiency. Okay. So in this particular experiment, what is our experiment title? Shell and tube heat exchanger. So we have found two major results here. One is in terms of table, heat exchanger streamwise results. Another one is heat exchanger results by the way of doing this simulation. So what is this simulation? Water in, methanol in, two compounds we have given, and we have got the outputs, water out and methanol out with respect to the temperature and pressure. Okay. So please all of you try this. If you have any doubt, please ask, or if you want this algorithm sheet also, I will show to you. Any of the steps, if you could not follow from me, please ask again, I will tell. I'm showing this algorithm sheet also with you.
Sir,
Yeah, please tell.
sir, value லாம் கரெக்டா போட்டேன் sir, but ஆனா எரர்னு வருது sir.
Can you show your screen? Can you show your screen?
Sir, phoneல வச்சிருக்கேன், ஒரு நிமிஷம் மாத்திட்டு வரேன் sir.
தம்பி உங்க முதல்ல சொல்லல தம்பி விஷ்ணுவர்தன்
சொல்லுங்க sir.
every time I am telling you have to use only the other day is I am going to put action.
இல்ல இதுல
How many
பண்ணிட்டு
times I will tell you, I am going to put action. This is the, I think, fourth or fifth class this one is. Isn't it?
சார் நான் phoneல பண்ணிட்டு இதுல பிசில
நீ
பண்ணிட்டு
எந்திரியே பண்ண வேண்டாம், நான் சொல்றது நீ முதல்ல கேளு.
இல்ல சிஸ்டம் ஸ்லோ ஆயிடுச்சு சார் எனக்கு, அதான் சார்.
நீ ஃபர்ஸ்ட் சிஸ்டம் எப்போ நல்லா ஒர்க் பண்ணுதோ அன்னைக்கு வா, அது வரைக்கும் ஆப்ஷன் போடுறேன்.
சார் இல்ல சார், இதுல கனெக்ட் பண்றேன் சார், பண்ணிடுறேன் சார்.
கனெக்ட் பண்ணிட்டு அவுட்புட் காமி.
Others also, I hope you are doing. Please do it and show the outputs.
Students, hello, students, can you able to hear my voice? Hello.
Yes, sir.
Yes, sir.
So all of you have to follow whatever sir told you. You have to follow the protocol and you have to get the output. Okay. Now the time is 3:42. I will by 4 o'clock I will call one by one. You have to show your output. Okay. I want to check. Okay. Just I will give an all of you. Just I will give an introduction about what is this special and tube heat exchanger. All of you wait. And I will present in
Sir. Sir.
And Vishnuvardhan. Okay, got it. Otherwise,
Vishnuvardhan,
Yes.
you
you
stop
stop.
your presentation. You stop.
புரியல சார் என்ன?
Vishnu, you just stop,
Presentation stop
you
பண்ணுங்க.
wait a few minutes. Sir will give a lecture, and later we will discuss yours.
ஓகே சார், ஓகே சார்.
All of you can able to see my screen? Hello?
Yes, sir.
Okay. Sure. Okay, all of you just listen. Within 10 minutes, I will explain what is happening in a shell-and-tip heat exchanger and what we are going to do. That I will explain in simple words. I will explain. Okay. See, in the previous experiment, we did the double pipe heat exchanger, isn't it? Okay. Today we are going to simulate the shell and tube heat exchanger. If you take, okay, this is double pipe heat exchanger, shell and tube heat exchanger. All heat exchangers are indirect contact heat exchanger. These are all the examples for the indirect contact heat exchanger. Indirect contact means there is no direct contact between the hot and cold fluid. No direct contact between the hot and cold fluid. Okay. Therefore, here these two will be separated by using wall. Okay, see here, this is the shell and tip heat exchanger. The schematic representation of a shell and tip heat exchanger, assume. Okay. Okay. See here, one fluid will be flowing inside the tube. This is the tube, and the other fluid will be flowing through the outside shell. Okay, that's why it is called a shell and tip heat exchanger. And we have different geometry of the shell and tip heat exchanger. That is 1, 2, 1, 1 shell and tip heat exchanger. The meaning is one shell pass and one tube pass. 1, 2, 1 shell pass and 2 tube pass. 2, 1, 2 shell pass and 1 tube pass. Like that, you know, we have n number of arrangements, flow arrangements are there. Okay. But all this shell and tip heat exchanger and double pipe heat exchanger both are, you know, it is an example for the indirect contact heat exchanger. That is, there is no direct contact between the hot and cold fluid. Here we have taken two different streams. We have taken, one is methanol and the other one is water. Isn't it? Okay. The temperature, normally the hot fluid will be the hot fluid mean which can be easily converted into vapor. Okay, because the latent heat, okay, see here, in any fluid, two types of heats are involved. One is the latent heat and other one is the specific heat. Okay, the amount of the latent heat will normally be higher than the amount of the sensible heat or the specific heat. That's why the hot fluid will always be used in the form of a vapor. Most of the times it will be used in the form of a vapor only. If you take methanol and water, methanol can be easily vaporized. Therefore, it can be taken as the hot fluid. Therefore, here we want to find out, assume that this is the methanol input and this is the methanol input and this is the methanol output here, methanol output. And the cold fluid, we have taken the water input and this is the water output we have taken. And we want to find out, and in the simulation what we are going to do, we will supply all the input and we will be checking what would be the output for the corresponding to the input. That is our objective. See here, the input of methanol, input of the inlet temperature of methanol, inlet temperature of water. Sometimes the outer temperature of water may be given, and you may be asked what would be the outer temperature of methanol. You will be asked. Okay, what will happen to the outer temperature of the methanol? Okay, the heat transfer process not only depends upon the nature of the fluid. I mean the compound which we have selected. If you select ethanol, definitely the heat transfer process will be different. If you take oil, its heat transfer process will be different. Okay, therefore the heat transfer process not only depends upon the nature of the fluid and its temperature, it also depends upon the geometry. Geometry, I mean the heat transfer area. How much is the heat transfer area? We know the definition for the heat transfer rate. Q is equal to what? UA del T, isn't it? What is this AU? U is the overall heat transfer coefficient. In our case, or in simulation, this overall heat transfer coefficient is represented as global heat transfer coefficient. They are using the word global heat transfer coefficient, which represents the overall heat transfer coefficient, capital U. If the capital U is more, then automatically the Q value will be more. Then similarly, if A is more, A is nothing but the heat transfer area. Heat transfer area is nothing but the contact area between the hot and cold fluid. If the contact area between hot and cold fluid is more, the heat transfer rate will automatically will be higher. And the del T, del T is the here they are with the del T is the temperature difference between the hot and cold fluid. But if you take a Shell and heat exchanger, the del T is not a constant. Del T is the temperature difference between hot and cold fluid. Okay, from the inlet to the outlet, if we check the temperature of both the fluids, it will be changing. Therefore, what temperature we have to take? That is the question here. In that case, we have to take the log mean temperature difference. We know how to take the log mean temperature difference. What is the log mean temperature difference? The formula for the log mean temperature difference is del T1 minus del T2 divided by ln of del T1 divided by del T2, where del T1 is the temperature difference at the inlet between the hot and cold fluid, and del T2 is the temperature difference at the outlet between the hot and cold fluid. Okay. Therefore, using that one, we can find out the log mean temperature difference. Therefore, the heat transfer rate Q depends on so many things. That is the nature of the fluid, its inlet temperature, it is a specific heat, then heat transfer area, overall heat transfer coefficient, and the arrangement also. The arrangement means especially the baffles. The baffles are used to create a turbulence in the shell side. If you produce a turbulence, automatically what will happen? The heat transfer rate will increase. The overall heat transfer coefficient, capital U, that will change. Okay. Therefore, in order to create a turbulence in the shell side, they have provided a lot of baffles. Okay, the baffle may be 25% cut baffle, or it may be 75% cut baffle, like that. Okay, different types of the baffle they have used. And the heat transfer rate also depends on amount of the material which is passing. That is the mass flow rate of the both the hot and as well as the cold fluid. Okay, therefore amount of the fluid, nature of the fluid, temperature, specific heat, overall heat transfer area, then overall heat transfer coefficient, LMTD, so many factors are affecting the heat transfer rate. Okay, therefore here what we are going to do, we want to find out what will happen to the outer temperature of any one of the fluid we can take, and rest of all the parameters we are going to supply some data. Then only we can simulate, because it is not possible to simulate 3 or 4 variables at a time. It is not at all possible. Okay, if a phenomena is affected by 10 variables, what we have to do, at least 7 or 8 variables we have to supply the data. Okay, then after that we can simulate the rest of the things. What will happen to the output? If this is the input, what will happen to the output, that we can study or that we can simulate. That is what we can do. Therefore here, because of that only, the overall heat transfer rate U value is given, overall heat transfer area A value is given, log mean temperature difference also is given, and the property. The property means the specific heat, everything, everything it will calculate. If you give the name of the component, then automatically it will select the properties. Okay, like a pressure drop also we can calculate. The pressure drop, everything can be calculated with the help of Raoult's law. What is Raoult's law? Raoult's law relates the liquid composition and the vapor composition, isn't it? Okay, if the liquid composition is this much, vapor composition will be this much, like that. Okay, for that reason only we have selected Raoult's law, because Sometimes we may be asked to find out what is the pressure drop when the hot fluid enters at one point and it leaves at some other point. The distance between inlet and outlet may be 2 meters. Along 2 meters, what will happen to the pressure drop? How the pressure changes? That also you may be asked to find out. Okay, in that case, we should have some package to calculate all these properties like temperature, pressure, volume, everything. For that reason only we are using some package. That is the Raoult's law like that. Okay, we are using some from equation also we are using. Okay, therefore here the ultimate objective is the most of the inputs are given and you are asked for this set of input. What will happen to the output? If any one of the input parameter changes, then automatically it will reflect on the output temperature of the both the fluids. That is both the hot fluid and as well as the cold fluid, isn't it? Okay. Assume that if the overall heat transfer coefficient, I think you have given us 250 like this. Heat transfer area, you have given us 250 meters square. If you change the heat transfer area like 400 meters square, then the output value of the temperature will be different. Okay. Similarly, each and every parameter what you have given as the input, if you change, automatically the output value will definitely will change. Okay. Therefore, our objective is, say, assume that I have an heat exchanger. It is a old heat exchanger. I want to do. Sorry. I have an heat exchanger. It is an old heat exchanger. Okay. And I was using that heat exchanger for the exchange of heat from oil to water. Oil is the hot source here. Water is the cold fluid here. Okay. Then I was using that one for quite long time. Now I want to use the suitability. I want to check the suitability of the given of the heat exchanger which I have in my hand for the ethanol and the water system maybe. Okay, in that case, you know what I will be doing. Okay, if I know the parameters, okay, like if I know the temperature, pressure, and other parameters for ethanol, you know, I can substitute all these values here, and I can find out, okay, whether the given whether the heat exchange which I have in my hand is suitable for using ethanol and water. I can find out, or I can find out what will happen to the efficiency of the heat exchanger if I use ethanol and water instead of using oil and water. All these things without conducting experiment, I can find out. That is the beauty of this simulation. Okay, all of you can able to understand. Okay, therefore here we have given a set of value like mass flow rate, temperature, everything is given. Okay, if we change any one of the parameter, definitely it will have its own reflection on the output values. The output values is nothing but the output temperature and output temperature of the hot and as well as the cold fluid. Okay, and then if I know the output and the input and output temperature, everything I know, sometimes I may be asked to find out how much heat transfer I need. Assume that I don't know how much heat transfer area. Okay, therefore, and you may be asked to find out the heat transfer area required for the given input and output value of the temperature. Okay, you may be provided with what is the input temperature of the water, input temperature of the ethanol, and output temperature of water and output temperature of ethanol. Everything will be given, but you will be asked to find out what will happen to the heat transfer area for this set of condition. Okay, that also you can find out by simulating this one. Without conducting experiment itself, we can find out what will happen to the heat transfer area. Similarly, the overall heat transfer coefficient, that is affected by the fouling factor. All of you know that fouling factor. Fouling factor means if any scale forming material is present in water, that scale forming material will form a layer on the either the inside of the pipe or outside of the pipe. Okay, the thermal conductivity of this scale forming material will normally it will be very, very low, and because of what will happen, the overall heat transfer coefficient will go down. If you are provided with the thickness of the scale forming material, in that case you can find out what will happen to the heat transfer coefficient, the overall heat transfer coefficient U. for the scale which is formed for a given thickness. Okay. Now this is the beauty of the what is this, the simulation. Okay, therefore a phenomena is affected by n number of variables. Okay, you can fix it, maybe 10. If a phenomena is affected by 10 variable, you can fix 9 variable, and you may be asked to find what will happen to the 10th variable. Okay, that is how we are going to do the simulation. Okay, all of you, I will ask one by one. You have to show. I will give you 10 minutes time. By 4:10, you have to show your. I will call one by one. You have to show your screen. What is it, sir? இந்த பனி வெடிப்பு இன்னும் ஆறவே மாட்டேங்குது சார்.
சார் உங்க ஸ்கிரீன் ப்ரெசென்ட் பண்ணது ஆஃப் பண்ணிடுங்க. இல்லை இருக்கட்டும் அது.
இல்லை ஆஃப் பண்ணாலும் அவன் ஸ்கிரீன்
1% பண்ணுவோம்.
இது வரைக்கும் சொல்லிட்டாங்க.
Sir? Sir?
Yes.
Sir, எனக்கு
ஜெயவாணி.
Sir, shell and tube properties மாத்திரம் sir, but sideல எனக்கு resultsல வந்து 0 னா காட்டுது.
In which place you are saying?
Um,
In flow sheet, have you run the program, run the simulation?
yes, sir.
Okay. After that, what it shows? Whether you get these calculated values.
No, sir. It shows zeros.
Verify it whether you have defined your water in and methanol in properly.
Okay.
You just click on water in. Suppose here you just keep cursor. I show my screen to you. You keep your cursor on water in. It shows all the properties. Whatever I have given the properties, it shows 10 degrees Celsius, pressure 1 bar, everything. Like that methanol. Okay.
Okay, sir.
So like that, you just verify it whether you are getting.
Okay, sir.
Sir? Sir?
Uh, generally, when you get an error, okay, so when we get error normally, we miss any of the logical sequential operation, okay. So all these processes are logic, okay, whatever we do. Even it is so simple, we don't do any programming. Anyway, we give inputs to the simulation. So when we do give inputs, if you do any wrong inputs, okay, which is not logic, it's obvious that you will get some error. Sir, how can we correct the error without depending on someone else? Okay, I'm teaching you that how you yourself can correct error. When you are learning any software package or whatever it may be, need not to depend anyone. Even we have it as a laboratory session separately, but the sir is giving lot many inputs to you. So the class is not limited with what a source lecture or what the assistants like we, myself or Siva ma'am is teaching to you in terms of how we have to give inputs and so on. You need to practice a lot. Okay. So any error comes, you just check the way you have proceeded the steps immediately one way. Another way you can check for errors in your Google, because normally when you uh, try with Googling, normally anything these days we do Googling, but when you are learning newly, for every error, whenever the error comes, the error names, if you or error syntax, you just search, it will give what type of error it is where we have done mistake. Many people have written articles on that. Okay, many blogs are available for this particular package. What we are doing as DW sim also, there are blogs are there. So if you Google it, the results are available for that. Where suppose you could not find out where you have done mistake, easily you can identify. Okay, so you simply verify it whether you have followed the steps. That is a simple thing. Even if you tell me also what I will say, you just show every step individually. I will ask. That is the only thing, only way we can easily do. Okay. And for example, earlier Jayavani asked, sir, buffle cut is it 20 or 25? So I am from maths department. We know some of the packages normally how we have to run. I don't know very deeper about some of the physical phenomena or physical characteristic of all these parameters. Okay, so whatever sir explained, whatever you have studied in chemical engineering, I do not know very thoroughly. I learned from sir only. Okay, and you should know that. You should know about that physical phenomena, whatever it is, physical characteristic of different material. And suppose you don't know, when you are coming to the class, you forgot what you have learned in the earlier theory classes, do not bother. Just check at that moment. Okay. And I hope you're all doing. I want to show one thing from Sir's word. Uh, I'm presenting my screen to you. So here, sir said that, like, suppose something is given as input, something is asked, what you will do. For example, water in, methanol in, water out, methanol out, it is given. What are all the different heat exchanger values will come? If if all these values are defined, water in, water out, methanol out, already defined. Sir, in this particular simulation, you have defined the inputs of water in, methanol in, and then you have defined the properties of heat exchanger. Then we get the output. So, output of what is water out and methanol out. Okay. So suppose we could define water in, methanol in, and we need this water out and methanol out. Then what type of these heat exchanger values? So just now, sir has discussed U, A, delta T. Is that right? So what is global heat transfer? What is heat exchange? What is logarithmic values? Okay. So whatever sir has discussed with you. So everything you have to find out. If you know water in, water out, methanol out. Here we have to define, that's all. How water in we have defined, the same way water out and methanol out has to be defined. Okay. Suppose you finished, you just show your outputs.
என்ன டேட் சார் இன்னைக்கு 16 இல்லைங்களா? 16/2. அடுத்த தடவை வந்து ஒரு 2 எக்ஸ்பெரிமெண்ட்டுக்கு கொடுத்தேன். ஓகே, பரவாயில்ல. 2 எக்ஸ்பெரிமெண்ட் கொடுத்துட்டு 2த்துக்கும் அவுட்புட் காமிக்க சொல்லிடலாம். Number 1, Ria. Ria is there. Number 1.
Yes, sir.
Okay, can you share your screen?
Yes, sir.
Show me the output.
Sir, for heat exchanger, I got everything 0. I couldn't. It was different values.
I think something wrong with your input. And second thing, the color of the simulation chart is also not. Sir, it should be in blue color. Yeah. You have some, whatever the data you supplied, that is different, I think. That's why you are getting a different, you are getting a red line also. You are getting. Okay, do you have the procedure with you?
No, sir.
You don't have the procedure? Google Classroom, we check the Google Classroom. SAR uploaded this procedure. Okay, just follow
Okay.
the procedure. Okay.
Okay, sir.
Input value is wrong. Okay.
Okay, sir.
Okay, number 2.
So, friends, one thing, please understand, when you are doing the simulation, I share my screen, you just see once. See here, my simulation is pakka. It is finished. It is finished correctly. So if it is error, okay, so here, what is the simulation we are doing? Through heat changer we are doing. So if it is any error, the red color will be shown in that place. Now you just look at in my screen, everything is in blue color. Is it right? Okay, so that is one of the symbol that you have done an error. Even this red color will be showing related with where, in which component you have done also. Error also, where is the error also. That is the way also you can find out where is the error. Okay, and I have uploaded this procedure also in GZR. You can check it and you can redo it. Suppose you could not recognize the error, you just follow the steps again and verify it. Okay.
Number 2, absent. Number 2, what happened to number 2? He is absent for, I think, for all the lab, he is absent. Number 2, Animesh Tiwari is there. Okay. And number 3, Vaishnavi Praveen.
Sir, my laptop is updating, so I am using phone.
You have to see, all of you have to use only your laptops. From the beginning, I am telling. You people are telling n number of excuses. Sir, this thing is not working, that thing is not working. I will simply put absent for you people if you do like this. Okay, well, next class onwards, you have to get ready. Okay, you have to use only your laptop. Otherwise, I will put absent straight away. I will put absent only because I don't know whether you people are doing or not. How I will it's difficult for me. Okay. Number 4.
Yes, sir.
Show me.
Okay, sir. Sir, can you see?
Okay, I think you are getting correct value, I think.
Okay.
Okay. Number 5. Share your screen. Number 5. Number 5. 5 is there or not? Say yes or no. Number 5. Number 5 is there or not? Number 5 is absent. Okay. Number 6. 6. Number 6. Students, can you able to hear my voice? Hello?
Yes, sir.
The number 6. Number 6, share your screen. Number 6 absent. Number 7.
Sir, one minute.
Number 7.
Sir, you can one minute, sir. Sir.
What is the output temperature? What is the efficiency you are getting? 84 something. Thermal efficiency.
82.
Sure. Okay. 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 You can stop your presentation. Okay. Number 8. Number 8.
Sir, she has power cut. She'll join in 5 minutes.
Okay. Number 9.
Yes, sir.
Okay. Share your screen.
Sir.
It comes around 80
something.
உங்களுக்கு கரெக்டா தெரியல இந்த பாராமீட்டர்னா இவ்வளவு பெர்ஃபார்ம் பண்ணுன்றது உங்களுக்கு
அவ்வளவுதான் சார் வரும்.
நான் கொடுத்த வேல்யூக்கு 80.4 அவன் கரெக்டா பண்ணு.
Kritika, share your screen.
Yes, sir.
Next to Mukesh, get ready. Number 10. Mukesh,
Okay, sir. Okay, sir. Okay, sir.
Correct ah vandirukku. What is the thermal efficiency you are getting?
Sir, 49, sir.
Okay, check your input data.
Okay, sir.
Okay, sir shared one Word document, you go to the Word document and check whatever the data they have given, just put the data, you will get I think you know how to do, but you are getting a wrong value. That is the problem here. Okay, that's not a big problem. Just to give the correct input data. Okay. The next is number 10. Mukesh.
சார் எனக்கு இன்ஆக்டிவ்னு காட்டுது சார்.
அதான் நீ என்ன பண்ண, அந்த ரெட் லைன் இருக்குல்ல அது மேல வச்சு ரைட் கிளிக் பண்ணு.
பண்ணிட்டேன் சார்.
ரைட் கிளிக் பண்ணா என்ன போட்டுருக்கு பாரு, ஏதாவது மேல ஹீட் எக்ஸ்சேஞ்சர் ஆக்டிவ், ரீகால்குலேட், டீபக் ஆப்ஜெக்ட், டிஸ்கனெக்ட் ஃப்ரம் ரீஸ்டார்ட், கிளியர் க்ளோஸ். சரி, ஓகே ஓகே, யூ ஆர் கெட்டிங் எரர்.
எஸ் சார்.
You check the data, whatever the data you gave us an input, you check the data. Okay.
Okay, sir. Okay.
Select பண்ணிப்பாரு. Okay.
Okay, sir.
அதை வச்சு give the correct data. You know how to do, but the data what you have given, the steps you did not follow correctly. That is the problem.
Okay. Yes.
Okay.
Okay.
ஆமா, கீழே description இருக்கு தம்பி.
ஓகே சார்.
கீழே ரெட்ல இருக்கு description.
ஆமா சார்.
ஸ்டாப் ஷேரிங் ஒரு பார் காமிக்குது இல்ல, அதுதான். அது படிச்சு பாரு, அதுல என்ன எந்த இடத்துல ப்ராப்ளம் கொடுத்துருக்கோம்.
சார் அது படிச்சா எனக்கு புரியல, அதான் அப்படியே வச்சிருக்கேன்.
சரி, ஓகே, புரியலன்னா என்ன பண்ணு, திருப்பி வந்து பிகினிங்ல ஸ்டார்ட் பண்ணி சார் கொடுத்துருக்க அந்த ஸ்டெப்ஸ் அப்படியே கண்டினியூஸா ஃபாலோ பண்ணு கரெக்டா வந்து
சார் அதான் இப்போ நான் 2வது பண்ணேன் சார். ஆனாலும் எனக்கு அதே தான் வருது. அதான் என்ன ப்ராப்ளம்னு எனக்கு தெரியல.
நீ இந்த ப்ரொசீஜரை ஃபாலோ பண்ணு. 2% கேட்டு.
ஓகே
பிரச்சனை.
ஓகே. நம்பர் 11.
இல்ல நிறைய பேருக்கு இதே ப்ராப்ளம் தான் சொன்னாங்க சார். அதான் கேக்குறேன்.
தம்பி நிறைய பேர் நல்லாவும் பண்ணியிருக்காங்க. நீ அவங்ககிட்ட நல்லா பண்ணியிருக்காங்க. இப்போ அது யாரு ரியா நல்லா பண்ணியிருக்கு. தென் வந்து கிரண் நல்லா பண்ணியிருக்கு.
ஓகே சார் கேக்குறேன் சார். அப்போ
அவங்களாம் கேட்குறேன். ஓகே.
தேங்க்யூ சார்.
இன்புட் டெம்பரேச்சர்
நம்பர் 11.
Yes, sir.
Abhi, make it fast. Already the time is 4:30.
Yes, sir. Very good. Sir, can you see?
11. Yeah, it's coming now. உனக்கும் எரர் காமிக்குது. நீ முடிக்கவே இல்லை. நீ இந்த டேபிளே வரல பத்தியா? ஓகே. the input data
Same error adhidan sir. 2 errors.
இல்ல இவன் அந்த டேபிளே எக்ஸிக்யூட் ஆகல பாரு. டேபிள் இங்க வரும். சரியா? நீ சிஸ்டமேட்டிக்கா அதை ஃபாலோ பண்ணு. நம்பர் 12.
Okay.
12 நம்பர்
13.
சார் எனக்கும் அதை பத்தி தான் சார்.
நீ காமி உனக்கு என்னதான் வருதுன்னு பார்க்கலாம்.
லோடிங்.
நீதான் அவங்க சொல்லி கொடுத்தியா தப்பா?
இல்ல சார் நான் 3வது வாட்டி பண்றேன் சார். 3வது வாட்டி எரர் சார். அதான் சார்.
சரி அந்த சிஸ்டம் அந்த கொடுத்துருக்க ப்ரொசீஜரை சிஸ்டமேட்டிக்காக ஃபாலோ பண்ணு. அதில் இன்புட் டேட்டா ப்ரெஷர் டெம்பரேச்சர் எல்லாமே சிஸ்டமேட்டிக்காக.
ஃபர்ஸ்ட் வாட்டி பண்ணப்போ கொண்டு வந்துட்டேன் சார். இப்போ திருப்பியும் 3வது வாட்டி பண்ணேன் சார்.
திருப்பியும் அந்த மாதிரி ட்ரை பண்ணு. ஓகே. தென் நம்பர் 14.
Sir, while doing having network issue, sir. Got. So while doing network issue, sir.
Sure. Next 15. 15. Ami, can you able to hear my voice? Number 15. 15 is absent otherwise. 15 absent. Okay. The next 16.
So 16 got logged out. She will join within 10 minutes.
Who? Number 16 now?
Yeah, she will join 10 minutes within 10 minutes.
17.
Sir.
Okay, show your screen.
Yes, sir. Sir.
Share your screen.
Sir, can you see?
Yeah, it's coming now.
Yeah, okay.
I think correct. Thermal efficiency, how much you are getting? 27.
Yeah.
The input data is wrong. Okay, check your input data.
Okay, sir.
The next 18. Number 18.
Yes, sir. Yes, sir.
Share your screen. You have some error. Number 18.
Yes, sir. Same error, sir.
You check the input data and they have given some tips at the bottom. You check the tips, which is in red in color. The bottom. 1, 4, 2 something is there. You check that.
Yes, sir.
Okay, then change that one. Okay, number 19. 19 is
Yes,
there.
sir. Yes, sir.
Your screen. 19, okay.
Yes, sir.
Okay, number 20. Mm, 20. 20, share your screen. Number 20. 20 is absent, it seems. Then 21. Number 21. Charima, you proceed. Thermal efficiency 0. Sir, okay, something is wrong with your data. Okay, just give the proper input data, you will get. Okay, number 20, you can wind up. Number 21. 21. What happened to number 21? Why he is absent for so many days? Sir, okay, 22.
Present, sir.
Okay, can you share the presentation?
Yes,
Can
sir.
you share the screen?
Yes, sir.
Thermal efficiency 79 you are getting, isn't it? Okay.
Yes, sir.
More or less correct only. Okay, then you can stop your sharing. Okay, number 22.
Sir, I'm 22. I just shared my screen.
22, 23.
Yes, sir.
Share the screen.
Sir, it's showing unable to share the screen. Something went wrong, sir.
What is wrong?
It's not sharing, sir. Something went wrong. It's showing unable to share the screen.
Share 23, 25.
Yes, sir.
Share the screen. Thermal efficiency, how much you are getting? 0. Something
Sir,
wrong.
இது edit இதுல change பண்ணிட்டேன் சார் பட் எனக்கு ரிசல்ட்ஸ்ல சேஞ்ச் ஆகல சார்.
Run simulation அப்படின்றதா இருக்குதா? Sir, at last we have
இல்ல சார்.
isn't it? In between. Sir, you check your input data. Systematic input data வந்து check பண்ணி பார்த்துக்கோங்க. Okay.
Okay, sir.
Okay, number the next stage 26 location.
Sir, on power cut சொல்றேன் சார்.
என்னப்பா?
on power cut சொல்றேன் சார்.
சரி, கட் ஆயிட்டு போகும். இப்போ என்ன ஒன் டே ஆப்சென்ட் ஆகும். சரி. And 27. 27.
Yes, sir.
Share your screen.
I have shared, I think.
RTB%. What is the thermal efficiency you are getting?
49 point something.
Okay, something is wrong with your input data. Check your input data. Okay. Then 28.
Sir, absent, sir.
29.
Sir.
Yeah, share your screen.
Sir.
Thermal efficiency 79. I think it is correct only. Okay.
Okay, sir.
Okay. Next number 29, 30. Basha.
Sir, 2 minutes, sir. Unable to share this. நான் வெளியே போயிட்டு மறுபடியும் கனெக்ட் பண்றேன் சார்.
சரி வா. Thirty-one, share your screen. Bright Sun Samraja. 31, sorry, 31 absent. The next 32, Jyotinesh.
சரிங்க சார் பண்றேன். சார் 82.0757 வருது சார் தெர்மல் எஃபிஷியன்சி.
சரி ஓகே. ஓகே 33 share your screen. Thirty-three absent. Okay. 34.
சார் ஏதோ நெட்வொர்க் இஷ்யூ சார்.
விஸ்வா. சரி அவனும் absent தான்.
சார் வந்து திருப்பி லாகின் பண்ணேன் சார்.
35.
Sir, he had some server issue, sir.
Seri. The next 36.
Yes, sir.
Share your screen. அடுத்த இதுல சார் 2 போட்டுருங்க. 3 2 5 சரிமா. ஓகே 36 ஓகே. 37.
சார்
சொல்லு தம்பி.
சார் ஸ்ரீநாக்கு ஸ்டக் ஆயிருச்சாமா சார்.
என்ன யாரு?
ஸ்ரீநாக்கு.
இது யாருப்பா சீனா?
சார் 33.
ஸ்வீனா. சரி ஓகே. 37.
Sir, she have power cut problem.
37.
Yes, sir.
சரி நெக்ஸ்ட் 39. 39.
Sir, he had also have power cut problem, sir.
Okay. Then 40.
Yes, sir.
40. Share your screen. Okay, ma. 40, okay. Then 41. 41.
Sir, he is having network issue, sir.
Cherry. Okay. 42.
Yes, sir. சார் டேபிள் வர மாட்டேங்குது சார்.
டேபிள் வராட்டி பரவாயில்ல, நீ என்ன பண்ணிருக்கன்னு பார்க்கலாம்.
So, percentage. சார் தெரியுது சார்.
ஒன்றும் தெரியல. சரி, ஓகே. டேட்டாலாம் செக் பண்ணு, இன்புட் டேட்டாலாம் செக் பண்ணும். Then 43.
Okay.
43,
Yes,
share
sir.
your screen.
Yes.
42. 42, stop your presentation. 42. Calculation type. 43. Show your presentation.
Sir, is it visible?
It's not coming. Wait. Efficiency, you are getting 40%. Check your input data.
49. Okay. Sir. Yes, sir.
So, yeah. Okay. 44. First water into 1 ethanol 0, water 1 change 44. 44. Absent. Okay. All of you listen. Those who did not share the presentation, I put absent for all the people. Today, so many people, they did not show your presentation. Okay, therefore, I will put absent for all the people. Today, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. Okay, today 20 people were absent.
Sir, roll number 8, she'll present now. Her mic isn't working though. She'll present.
No, you have to show some presentation,
Yes, sir, she'll present right now.
Right now she is going to present. Okay.
Yes, sir.
Yeah, she can present. Number 8, you can present. Sneha Judge.
Yes, sir.
Sir, I'm presenting, sir. Can you see, sir?
Who?
So 44.
You did not show your presentation, isn't it?
Service, I'm showing. Okay.
44 did not show your presentation. Whose presentation is this one? 44. 44. Okay. 44, you can leave.
Sir, I showed you, sir.
Number 8.
I showed you
44, you can leave.
Okay, sir. Thank you, sir.
Then number 8.
Sir, 30. Basha, present பண்றேன் sir.
Basha. Present பண்ணு. 8 கொஞ்சம் வெயிட் பண்ணு. Okay, ma. Something is wrong with the input value, but you are getting thermal efficiency 27% something. It should be higher. Okay, but anyway, you check your input value, number 8. You can leave.
Sir?
Mole fraction 0.5, 0.5.
Sir?
Number 8, you tell me. 8, tell me, Sneha Judge.
No, sir. Her mic isn't working. That's right.
Sir, okay, ma'am. Number 30. எவ்வளோ வருது? 23. எவ்வளோ வருது? Efficiency 40 something, isn't it?
Yes, sir.
Sir, okay.
Sir. Sir, 20 தர்ஷினி வந்து கொஞ்சம் லேட்டா காட்டினாங்க, பட் காட்டிட்டாங்க. பிரசண்டா இல்லைன்னு இருக்காங்க சார். மைக் இஷ்யூ.
20 I put percent.
Okay, sir. Okay, sir.
20%. For the rest of the people who
16.
16.
16.
What happened to you? Why you did not present
So can I present it now?
your presentation? Okay, ma. Your efficiency is low, but anyway, no, you have to change your input data. Okay, you can leave. What is number? 16. Okay.
16, sir.
16, okay. Just of the people, those who did not share your presentation, I will put an absent for you. That's all. Because I am right from the first class, I am telling you have to share your presentation. But you people are not simply you are telling, sir, that problem, sir, this problem, sir. Okay. Therefore, I will put an absent. Okay, all of you. Thank you.
ஸ்பினா சார் போயிட்டாங்க ஸ்பினா.
ഇനി എൻ്റെ അടുത്തേക്ക് കേട്ടിക്കോ, ഞാൻ എല്ലാവരോടും പറഞ്ഞത് സ്ക്രീൻഷോട്ട് ഒപ്പിച്ചോ, അത് പൂശാ മതി. എന്നിട്ട് ഞാൻ ഇവിടെ ഇതും ചെയ്തു ഗ്രൂപ്പിൽ. ഫക്കിങ് കാണ്ട്.